Okay, so picking up where we left off, if we look at the smaller rectangle UVWX, the dimensions are 1 by 2. If we add all of the sides, 1 plus 2 plus 1 plus 2, we get a perimeter of 6 units. If we multiply the length times the width, we get an area of 2 square units. And now we're looking at the changes. So comparing to the original rectangle, I can see that we've gone from 6 to 2 and from 3 to 1. So the change in the side lengths is that they are 1/3 of the original side lengths. The change in perimeter, we've gone from 18 units for the original rectangle to 6 units for the new smaller rectangle. And so I can see that the perimeter is 1/3 of the original rectangle, as expected. And if we look at the area, so the area of the original was 18, and the area of the new smaller rectangle is 2. And so we have a change of 1/9. The new rectangle is 1/9 of the original when we're comparing the areas. So on the next page, we're going to walk through a similar problem, but this time we have a triangle. So for activity 3, we have triangle ABC. On the first grid, they want us to draw a triangle with side lengths twice as long as the image they give us. And on the second grid, they want us to draw a triangle with side lengths half as long as that image. So before I make the triangle twice as long, I'm going to count out the distance from A to B on the original triangle. So I see that it is 8 units from A to B. Now, side AC and side BC are on a diagonal, so I can't count the units like I did for AB. But what I can do for this triangle is note that to get from point A to point C, if I'm only moving in the vertical and the horizontal direction, I would have to go up 1, 2, 3, 4 units, and then I would head to the right 2 units. So that will help me when I need to double the size of this triangle. So if we're going to double it on the first grid, that means I'm going to make the base 16 units instead of 8. So I'm multiplying the base by 2. Okay, so I have a base of 16 units. Okay, now to figure out the top of the triangle, from the point over here on the left-hand side, instead of going up 4 and right 2, I want to double those distances. So I want to go up 8 and right 4. So from this point in the bottom left-hand corner, I'm going to head up 8, and then I'm going to go in 4. And this is where the top of the new triangle will be. So I'm going to connect that point to the bottom left corner of the triangle. Oh, having a ruler would have been a good idea. And I'm going to connect that point to the bottom right corner of the triangle as well. Now they want us to label the new triangle DEF. So starting in the bottom left corner like they did for ABC and going counterclockwise, this will be triangle DEF. Now on the second grid we want to make the triangle half the size. So we're going to cut all of the lengths in half. So from A to B we have 8 units, and we're going to multiply that by a half or divide by 2, and that would give us a base of 4 units. Now from that point in the bottom left corner again, instead of going up 4 and right 2, we want half of all of those distances. So we're going to go up 2 and right 1. And if I go up 2 and right 1, I can find the top of the triangle, connect it to the bottom left corner and to the bottom right corner. This new triangle is GHI. So in the bottom left corner and then going counterclockwise, triangle GHI. And now we have some questions. So for number 6, describe the method you use to double the length of each side. So it's not quite as easy to explain as it was for the rectangle because remember 2 sides of the triangle were on a diagonal. So we can say that we multiplied the bottom length which was 8 by 2 to get 16. And then for the other sides, we want to describe that method we used. We knew that we had to go up 4 and right 2, so we doubled that distance and went up 8 and right 4. So I'm going to say for the other sides, I counted up 4 from point A, and over, or we'll say, and right 2 to get to C. So I doubled those distances to get from point D to point F in our enlarged triangle. So now we need to explain how we made each side of the original triangle have a length half as big. So I'm pretty much going to write the same thing except change a few words. So I multiplied the bottom length by 1/2 to get 4 from 8. So we originally had 8 units for the bottom length, multiplied it by 1/2, and that's how we got 4. And I used the same method as noted in problem number 6 to find the new lengths of the other sides. So remember, instead of going up 4 and right 2, everything was half. So we went up 2 and right 1. Similar methods. All right, number 8. Do you think the angles of the new triangles are the same or different than the original triangle? So when we think about a problem like this, we want to note, and I'm going to go back up so we can see those triangles. We want to note that the triangles, the original, the enlarged, and the one that's smaller, are all the same shape. What's different about them is the size. But imagine if we were going to enlarge a square or a rectangle. A square and a rectangle have 4 90-degree angles. If I double the sides of a square or a rectangle, or if I cut them in half, the new square, whether it's bigger or smaller, will still have 4 90-degree angles. So when we change the size of these images, whether they're rectangles or triangles, the angles are not changing. The side lengths are, but the angles are the same as they were in the original. So the triangles that we see up above are the same shape but their sizes are different. So the angles remain the same. We could say that the angles are preserved, meaning if we had a 30-degree, 60-degree, 90-degree triangle and enlarged it, the side lengths are larger than they were, but the angles are still 30 degrees, 60 degrees, and 90 degrees. So the angles are preserved, they do not change, but the side lengths can get bigger or smaller, depending on if we're enlarging it or decreasing the size. On the next page, number 9, is asking us what we think happens to the perimeter. So just like we saw with the rectangles, when we double the side lengths of the triangle, we expect the perimeter to double. When we halve the side lengths, we expect the perimeter to halve as well. So the perimeter will double when the side lengths double, and the perimeter will be halved when the side lengths are halved. So the side lengths and the perimeter change at the same rate. The area, of course, is different. So remember, the area is actually going to be 4 times what it was when the side lengths are doubled. The area will be 1/4 what it was when the side lengths are halved. So the area will be 4 times the original when side lengths double and the area will be 1/4 of the original area when side lengths are halved. Okay, and in the next portion of the video, so I'm going to stop, and the next portion will be a third video, but we're going to look at some similar triangles in Activity 4. So get caught up in everything we've done so far, and the third video, we will go on to the fourth activity.